All right, what you're going to need for pH tests: red and blue litmus paper, hydronium paper. Hydronium is the ion that you're testing for, its concentration. And some sort of metal thing to pin the paper down. You're also going to need some paper towels, which you can see right there. All right? And now I'm going to model how to do the test. So one last thing. Some people think to dunk it in. You don't, it's not the best way. I think it's easier and safer when you have more control. You take the solution and take a pipette or some sort of dripper or eyedropper, and bring the solution to the pH rather than dunking it in the solution, as I'm going to model here. All right. So I'm going to dip a plastic pipette into my solution and then put it on the pH paper. All right? All right. So here is some vinegar. Okay? Vinegar should be a weak acid. All right? Now, I just realized I don't have goggles on. I should have goggles on. All right? So you can see there's no change there on the red. So red to red means you could have an acid or you could have a neutral solution. Yep, now you see the blue to red means that this is an acid. All right? And then I test it on the hydronium paper. And there you go. Now, you compare this to this, all right? And you can see that's like a, oh, can you? You can see that that's like a 1, so it's pH of 1. Now that's kind of a strong acid, and there's a little more in terms of strength of acid than just the pH. So we're going to do this with a different solution. All right, now you can see that one, it's hard to tell in the video, but to me this one is a little more orangey, and that's like a 3 or 4. All right, the hydronium paper tests for strength, whereas the pH papers, the blue and the red, test for type of solutions, acidic, basic, or neutral. All right, you can smell that vinegar. Yeah, this is more orangey and that's more red. All right, now, a strong acid should produce the same kind of color changes. Let's see. Right? Good. Now notice I'm not like dousing the entire thing in it. I just need to touch it really to the solution and change it. And the metal thing is to hold it down. All right? Ooh, that's a vibrant red. All right? Now, then I would compare the hydronium to it, all right? And you can't because there's a glare. Yep, that's a strong red, all right? So once again, red and blue test for type of solution, acidic, basic, or alkaline sometimes called alkaline. Acidic, basic, alkaline. Basic and alkaline are synonyms. And the hydronium paper, this thing, tests for the strength or the pH of the solution. Strength in terms of pH. Now a strong base, I've got some sodium hydroxide, sodium being an alkali metal. All right. Now it should turn the blue, it shouldn't do anything. All right. So blue to blue means a base or neutral. And there you go. Red to blue means base. And then I test it here. All right, you can see that's like a bluish color. All right, and then I would test the hydronium paper and make a judgment call. All right, so blue to red, base, blue to blue, sorry, red to blue, base, blue to blue, base or neutral. Now here's a weak base. All right. All right. All right, so there. Now, this may be harder to see. That's more of a green color, and that's a red color. So there's a bit of observational error here. But it looks different in person. But the green would give it like a pH of 10, and the blue is like a pH of 12 or 13 or something, or even 14. So red to blue means base. Blue to blue means base or neutral. So you really need to test the solution with both of these, both red and blue, to know which way it is. Because if you test it with just blue, you may be like, oh, it's neutral because it didn't change it, but it really could be a base. All right? And the same thing goes with acid. Now, I wanted to show you water to illustrate one point. Ooh, see, I used way too much for that. This is like a squirt bottle. This would not be what you want to do. Good thing it's water, because what you tend to do is you tend to really squirt it. Now, one thing that's common here with pH, you can see it didn't change either of them, but some people, when they look at this with the hydronium paper, they're going to say like, oh, that's turning dark orange. It's a 4. This is an acid. But if it were an acid, this would turn pink. The blue would turn pink. So there's a degree of observational error here if you rely solely on the hydronium paper. So people think, oh, it's turning it orange, but it should turn the blue like it's too sensitive. All right. So just to recap, the red and blue tests for type, and the hydronium tests for strength. Red to blue means base. Blue to red means acid or neutral, and red to blue means base. Blue to blue means base or neutral. And remember, the hydronium, there's a degree of error there that you got to be wary of.